Hello everyone, and welcome to another SunCat Byte. In this SunCat Byte, we're going to talk about scope, and specifically global, local, and static variables. So scope determines which variables in the program are visible to other portions of the program and dictates how long a variable is available while the program is executing. So what it basically does is it dictates how long the variable is visible or available in memory. Okay? Includes the ability for one portion of the code to access a variable in other parts of the code. And the scope is determined by where the variable is declared. Okay, so we have one type of variable, which are local variables. And local variables would be variables declared within the function and function header line are local to that function, or they belong to that function, could be another way to look at it, are local, or you could say they belong to that function. So if that's the case, no other function can see, access, not spelling very well, can see, access, or change these variables. So the variables come into existence when the function begins execution, or they're in memory during that time, and are destroyed once the program exits the function. Another name for these is automatic variables. Okay, so those are local variables for a function. We also have block scope, or the idea of block scope. And what block scope is when you declare a variable inside a set of braces or curly braces, which are these, that variable exists inside that block of code. An example of this would be what? If statements, for loops, while loops, etc., right? Those all have curly braces. So once the code moves beyond the braces, variables out of scope. Okay, so then the variable is only good while it's in the scope. Now we have another concept of, oops, don't want to save. Global scope, or global variable. So let's do this guy again. Global variable is declared outside any function and is visible to all functions in that program file. All functions can use a global variable. And global variables are declared above main. And since they're global, there's no need to pass them between functions. And we'll see an example of this in a second. You should use global variables sparingly. Darn it. And typically when you want to use them will be for mathematical constants, maybe file pointers or stream variables, which we'll get to later in the semester. And the reason for that is if it's very large and there's a lot of user-written libraries, then you could step over. If you use a global variable, you can have a conflict with another variable that's already been defined. We'll see an example of this shortly with a math variable, CMath. So let's take a look at an example. Looking at this figure, we have a main, or a couple different functions. We have void, say hello, int count, here written one way, and here we have it another way. Okay, so we have void say hello, int count, that's the prototype. I'm sorry, this is the whole program. This is the program with main. So we have void say hello, int count, that's the prototype. Then we have string name. Then we have int main. And then we have name equals Bob, int count equals 5. So looking at these things, this is a global variable, string name. It's declared outside of any function. So it's outside of main and outside of the say hello function. So name is global. Here we have int main. It's in these curly braces, and it's also in the main. We have name here, but it's in the curly braces, right? It was declared outside, so you can just set it. Name equals Bob. Now we have int count. Int count gets declared inside of main, so its scope is just local to main. So count only exists in main, and then also it's calling functions, right? So we have count here. Count is equal to 5. It's local to main, but it can be passed to say hello. So now we have say hello count. So what happens there is we have two count variables, right? We have a count here. This one's in main, that was declared in main. It has a value of 5 right there. Then we get another, so then we say hello count, that has 5. Now we have void say hello int count. That count variable, because it's called by value or passed by value, is another count, but its scope is say hello. And so that 5 gets copied here to this other count, so now that gets a 5. So then we say int I. So now we have I, who only lives in say hello. I lives in say hello. It doesn't have a value initially. And so we say if the name is equal to Bob, for I equals 0, I less than count. So let's say it is equal to Bob, I is equal to 0. I get set to 0 there now. I less than count. So is 0, or is I less than count, is 0 less than 5, it is output high. So we're going to output high 5 different times, right? This is going to increment. It's going to go through 0, 1, 2, then 3, then 4, then 5. Okay? And each time we do that, it's going to output high. So after it's done that, we're going to come down here. We don't execute the else, and we leave the function. When we leave the function, I is gone. The count that was inside of say hello is gone. And we only have this guy, this count. So we come out here, then we say return 0, and we exit main. Once we exit main, that's it for that scope as well. That's how scope works. You can actually have two count variables, right? One here, one here. Okay, so now we have another concept called static variables. So static variables once a variable is declared as a static variable, the variable contents are retained until the program is terminated. The variable is still visible to only to the function, and it is not seen by any other parts of the program. The first time is entered or called, the first time the function's entered or called, the static variable gets initialized. If there is no initialization, then C++ initializes it. C++ initializes it to 0. That initialization is performed only once. You only perform the static one time. And you want to use this if the function must remember, remember a value even after the program control has left that function. A static variable keeps its value until the program ceases to run or exits. Okay, and the format for it is going to be static and then variable type, then name, like that. So something like this, static float, or say static int total. That would be a declaration. All right, let's take an example, or look at an example of a static variable. So here we have this program. Ask the user to enter the amount of the item purchased. The function has a static variable which maintains or remembers the amount entered. So say it's basically you're out shopping with your wife or with your husband. So pound include IOStream and string. Here's our function prototype, our declaration. Here's float total. Float total is declared inside of main. It just looking at the other stuff, its scope is main. String answer equals yes. We're going to use 2 decimals. So we're going to say while answer is equal to yes, we're going to say total equals how much have you spent. Okay? And as we keep seeing yes, we basically can keep going back and shopping and keep spending more. Once we say no, then we're done. So let's say that we come in, we have total. Total is not going to have a value to begin with. Its scope is main. We have answer. Answer is yes to begin with. And then we have, so total equals how much have you spent. We're going to go into the function, float, how much have you spent. This total scope is main. This total scope is how much have you spent. It lives inside of that function. Okay? So this, as we come in, this total, we say static float total equals static cast float 0, 0, 0, 0. This is the initialization statement. It occurs only once. So it's going to get 0.0 that first time through. Then we're going to get float amount. So we also have amount here that lives within how much have you spent. All right, so we're going to say how much was spent this purchase. Let's say that we spent $20. So we have 20.00. We get that, we do a cin.ignore. Then we say total equals total plus amount. We could also say total plus equals amount here if we want to use an accumulation operator, right? But anyway, total is going to be what was in total before, which is 0 plus 20. So now total is going to be 20. Then we're going to return total. So we're going to leave this function. When we leave the function, total doesn't actually go away because it's a static variable. Amount does. So we leave the function. That's gone. We return 20. So now 20 gets returned here. This total goes to 20. So now we have 20 there. We say, so you spent 20 total so far today. Keep shopping. I'm going to say yes. So we're going to say yes. We're going to come back in. We're going to loop up. Answer says, is it yes? Yes, it is. So we're going to go back into the function. How much have you spent? I go back into the function. This was the initialization statement, so this code doesn't get run. But I do have an amount again. So again, amount. How much have you spent? I'm just going to do how much ... And this should have been how much for the scope. Okay. So amount is now there. Float amount. So now amount's been created. There's nothing in it. How much was this recent purchase? Now we're going to say we spent $45.50. So amount is $45.50 right there. Total, it got read in here. Total is going to be equal to total plus amount. Total is still there, right? So total has 20 plus amount, which is 45.5. So that should give us 65.5. So then again, total return total. Total is going to get returned. Since we're exiting the function, that's gone. That total gets returned, so 65.5 gets returned here. Total is going to be 65.5 in main. Now this could keep going on forever if we want. But I'm not going to keep going here. So I'm going to say this time around that the user says, do you want to keep going? They say no. So then we're going to get your shopping trip today cost you $65.50. So let's go ahead and build that. And let's debug it. Start without debugging. How much is your recent purchase? We said $20 the first time around. If you spent $20, do we want to keep going? We said yes. How much this time? 45.50. You've spent 65.50 today, which is what we had in our example. Then we say no. Your shopping trip today cost you $65.50. So that's it. We're done. So that's how static variables work. Looking at global variables, program for 8 here. So looking at a familiar program, which is our ask for name age, which we actually took and broke into multi-file programming earlier. Notice we have our regular include using namespace standard, and here's our variables. Our function prototypes, right? Hello, ask for name, ask for age, and right. Here are 2 global variables. They're declared outside of main. So now I don't have to pass anything in here. Notice how these are all voids? As I go into the functions, it knows what age is because age was declared up here. So there's age. Don't have to pass anything in. The other version of this, right here, when we had to write, we had to pass these in, right? Because we read the values in, we read name and age in, and we had to pass them to this function. Here we don't because all of the functions have access to them. So name, age, and then that's it, right? So this will work the same as the other one because we're using global variables, so it saves us from having to have variables passed in there. So if we do this, as we do with our typical example, Bo, and of course I'm 21. Hi Bo, you're 21 years old. So that's an example of using global variables, not really harmful. Now, here is an example of using global variables somewhat harmful. Here we have the CMath library that we've included. We want to use it for square root in this program. Okay, so we have int main, we say y0 equals 500,000, y1 is the square root of y0, and then we want to output that. So we come in, we build this, and we get a bunch of compile errors. The reason for that is y0 right there and y1 right there, y1, y0 are actually defined in the CMath library. So you have a conflict. By using these global variables, you've actually overwritten some, or you've actually declared a variable that was already defined in the CMath library. So when you have large projects and people are writing their own libraries or their own functions, that's why you want to stay away from global variables. So it's always good to use global variables for constants like we said, and here we go, let me show you. Right here. So when you're using global variables, mathematical constants, file pointers, and stream variables. If you stick to that, you'll be safe. Well, that's it for this Suncat Byte. So global, local, and static variables. If you have any questions, comments, or concerns, please ask in the discussion board forum, shoot me an email, or I will see you during lab or office hours. Take care. Talk to you soon. Bye.